and welcome Mindsetters to this session of Learn Extra Live with grade 12s. I'm Ty and have Aslam here who's going to be taking us through today's session. What are we doing today, Aslam?
So we're continuing from last week.
All right.
We started with community ecology. We're going to do some questions, and from there we go to succession and some questions again.
Okay, awesome. So on that note, while Aslam makes his way to the board, Mindsetters, as I always say, make sure you get on the page, the link, www.facebook.com/learn extra. Let us know what you're thinking, if you're lost, if you need help, anything that you want to tell us, or if you have some awesome posts of your own, feel free to post up on the page. And remember, if you see a Mindsetter in trouble, help them out. But on that note, this is where I hand over to Aslam. Aslam, take it away.
Thank you, Ty. Welcome, Mindsetters. And that's the main thing, guys. We need to help each other all the time. That's the main thing. Make sure that you're watching what's on the page and post your questions. And those that have the answers, put your answers as well. We continue from where we ended last week. And to remind us again, I've put this little slide back up there to remind us that when we're looking at community ecology, we look at social organization first, and that deals with how a species is organized, social organization. So we looked at last week herds and flocks, hunting in packs, breeding hierarchies, and division of labor. We moved on to community structure, and there were three main headings there: predation, competition, symbiosis. Predation, we looked at that, and we're going to look at another question today on predation, so we're going to fill in the gaps wherever they are in predation. Under symbiosis, we looked at these three, we looked at examples, we answered some great questions on that, and we moved on to competition. And in competition, we looked at interspecific, intraspecific, resource partitioning. We looked at interesting questions in all of these. And the last one, competitive exclusion. We may touch on some of that a little later as well. We looked at community change, and that is where we're going to focus on today, mainly on this fellow here, community change, what happens in a community. But before we do that, let's get into some questions on predation. The first one here is adapted from March 2006 standard grade. That was before your NCS began. It was question 5.3. They say very clearly, study the graph below and answer the questions that follow. Beautiful graph. Again, remember, every time I put a graph question on the screen, I always take the time to remind you about drawing the graph. Look at the top. There's the heading. If you are asked to draw this graph, if you had this heading, remember, there are two variables: the relationship between a population of wild dogs and rabbits over time. The time here is one factor, and the population of these two animals is another factor. And there they put in one on the y-axis, one on the x-axis. The independent variable, that variable which is not affected by the other, is put on the x-axis, and in this case, it's time, and notice the unit is given in brackets years. And here, because it's years, you don't have to actually have divisions where you're going to start with 0 and then 1, 2, 3, 4. Because we're dealing with centuries here, years in a century, it becomes complicated to do that. So we can start with 1946, 56, and so on. But on the y-axis, because we're dealing with population numbers, if this is 0 and that's 100, then you've got to go right through in the same interval. 100, between 100 and 200, again 100. I always tell the learners, look at your ruler. Between 0 and 1, it's 1 centimeter. Between 10 and 11, it's still 1 centimeter. And the distance between the two lines will never change because they have the same interval. So make sure you do that. There's a heading there with the units as well. And your intervals are correct. You do not have to put these lines in your graph. And as you can see, in a case where there are two sets of data, if they say draw two sets of data on one axis, then you will draw two line graphs on the same graph. If you draw two graphs, the first one is marked, the second one null and void, 0, nothing, nada. Okay? In this case, notice also that they gave labels for rabbits and wild dogs. You can either do that, or you can provide a key on the side of the graph. I prefer if you label it, it's quicker, it's easier. You get a mark for that as well. So that's enough for talking about how to draw graphs, let's look at this particular graph. Over time, we can see that the rabbit population is fluctuating. At the same time, the wild dog population is also fluctuating. Now, sometimes in this question, they may not tell you rabbits and wild dogs. They may give you A and B. I'll tell you why just now. Now, here in this case, they want to know which population regulating factor is illustrated by the graph. And clearly, when we started, if you were listening, then you would have heard me saying that we're going to look at predator-prey relation. So this particular one is dealing with predation, or you can say predator-prey relations. You with me, guys? I'm hoping you're with me and you're following carefully. The next question, the graph is there all the time, so we're going to keep referring to the graph. Is this regulating factor named in question 1.1 a density-dependent factor or a density-independent factor? Now, here we're moving away, but I'm glad this question is here, because it shows you that while this particular question does not test community ecology, this part of this question, it goes back to population ecology, which talks about density-dependent factors and density-independent factors. So you need to know that in some questions, we can marry different sections in one question. In paper 2, we can do lots of that. In reproduction, for example, we can ask negative feedback. Negative feedback you learn in endocrine system, that's it. But reproduction has its own negative feedback in terms of FSH, estrogen, LH, and so on. We'll worry about that later. But for now, this is what I'm trying to tell you. So this is included here, but remember, in a question, expect to draw from different parts of the work. So here they want to know whether this factor, what's this factor? Predation or predator-prey. Is it density-dependent or density-independent? Obviously, guys, we need to know the difference between density-dependent and density-independent first. And density-dependent factors are those factors that regulate population that are dependent on the population size. And density-independent, obviously, are not dependent on the population size. So is this one here density-independent or density-dependent? Clearly from the graph, you can see that the one size of one population is regulating the size of the other population. So this is density dependent. So your answer here would be density dependent. Clearly, there, it's simple. We move on. Still with the graph. How many of the following were there in 1966? Now, guys, you know you do not have to be a rocket scientist, nor do you have to study anything to answer this type of question in this series, because they're asking you in this graph, how many are there? What they're asking you about rabbits. There's the rabbit population, is the solid line with the little diamonds, if you want to call it that. They go to 1966. There's 1966. You're going to take your ruler, go up, there's it there, go across. It's somewhere midpoint here, so the answer there would obviously be 50 rabbits. And they also want to know in the same year how many wild dogs were there. So 1966, this one is easy. Go up there, it's on the line, go across, and obviously, voila, it is 200. Your answer would be 200. Simple reading exercise. Now, guys, here, one point of caution. In the case where your line falls square on the line, you cannot have any leeway. You can't say 201. You can't say 199 because it's on that line. It's on the line. Right across, so you have to give 200. And where it's just off the line, if it was just below the line or just above the line, you still can't say 200 then because it's clearly in the graph, it's not on a line. And whatever is on the line is 200. So be very careful when you are using this type of scale. Use your ruler. You can use your ruler to measure the distance between 0 and 100, and you can make small lines on your question paper, and then you can work out more accurately what the actual figure is. This one was clear, not so difficult. Next question says, what is the maximum number of rabbits that have survived in this environment? Let's go back to this one here. Maximum means the highest. Again, no rocket science required here. You go right to the top. Where's the rabbit? These are the rabbits. There it peaked there. And across the line, that would be straightforward 500. Still with that question, what effect does a small number of wild dogs have on the rabbit population? Explain your answer. Very important. Note that there are two parts to this question. One is, what is the effect of a small number of wild dogs on the rabbit population? The second one says, explain. Why are you saying, what does it do? What is the effect can only be one of two things, or one of three things. One is increase, two is decrease, three is no effect. Okay? Notice I started by saying two, and then I realized it can sometimes have no effect as well. So that's the third one. So let's look at it. If there's a small population of wild dogs, what's happening to the rabbit population? It is high this side. When they get high, the rabbit population gets low. When they get low, the rabbit population gets high. So obviously, guys, it will increase. Now, why does it do this? We're talking about predator-prey. The prey being the rabbit. The predator being the wild dog. The wild dog is eating the rabbit. So if there's less wild dogs, if there are less wild dogs, there will be less animals eating the rabbits. Therefore, rabbit population will increase. To put it in more technical terms, you can even use the word that because there's less wild dogs, the predation pressure will decrease. What is predation pressure? The pressure that the predators put on the prey. So the predation pressure decreases, the population of the prey increases. When the predation pressure increases, when the wild dogs increase, then there's more predators eating the prey, therefore their population will come down. And we talk of the oscillating populations of these two. So the one population is controlling the other. If there's less prey, this also affects the predator because there's less food to eat. So the predator population comes down. If there's more predators, this affects the prey, and so on. They keep each other in check. Simple, 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 guys. Name one technique that can be used to estimate, the key word here, estimate the size of the rabbit population. First of all, guys, we need to talk about how do we determine the size of population. This is now, again, leaning towards population ecology. It's not part of community ecology. But can you see the link in this particular case? Yes, you do. Good. There are two methods that we can use, or rather two broad areas. One is direct, and the other is indirect. Direct means we must physically count the organisms, animals, plants, whatever. And indirect, we must estimate. So obviously, we're talking of an indirect method here. But they didn't just ask you the broad, they say one technique, one specific technique. And this technique, in the case of the rabbits population, because they are fast-moving animals, we cannot use simple sampling, so we use mark recapture. And I'm not going to go into the details of how we do mark recapture and so on, just that you need to know that this is how we do this is how we will estimate this population. Remember, the key there was how do we estimate? So the giveaway. If they said, how do we determine the population? Now, it could be direct or indirect. But, guys, let's face facts. Could you physically count all the rabbits in a particular ecosystem? In your yard, maybe, yes, small yard. But in an ecosystem like this, you think you'd be able to count all the rabbits? Remember, rabbits are fast-moving organisms. Could you do a census tie with rabbits? Hello, Mr. Rabbit. how many you got in your house, how many below 5. Could you do that?
Probably not likely.
Maybe on a Cartoon Network, but not
Yes.
in reality, right? On Cartoon Network, those rabbits, they talk. But now you all grown up. You're still watching Cartoon Network, but you know that rabbits don't talk back to you. Or at least we think that they don't talk back. We
If
don't
they
know.
do, might need some help.
If they're talking to you guys, get some help urgently. So obviously, census counting the rabbits would be difficult, so we had to go to the indirect, and the best way to do this is the mark recapture, because they are fast-moving animals. They don't stay in one spot all the time. If they were small, slow-moving animals, or if they were plants, we could use the simple sampling method. But like I said, that's for another day. With that, back to you, Ty.
All right, so on that note, Mindsetters, don't worry, I will be posting up pictures as we're going along, but make sure you stick around and come back as soon as we're done with this ad break. See you soon.